All right, so when we looked at probabilities, we would say, hey, our probability of some event is the number of outcomes in the event over the number of outcomes in the sample space. So let's look at a fairly complicated probability space. And so we'll have a company that has, let's see, let me get my numbers right here. We'll say 19 employees on the second shift, 12 employees on the third shift, and 21 employees on the first shift. And we want to randomly pick 8 employees. So we pick 8 employees out of these. Let's see, how many total employees do they have? 10, 2, 1, 52 employees. So we're going to pick 8 employees at random. And we want to know what's the probability that 4 of the 8 we pick are on the third shift. Now, I get a lot of questions like, why do we do this? And we'll find when we look at probability distributions, if we know the probability of a particular event, we can figure out the probability of repeating that event over and over again. And so if we wanted, for some reason, we wanted 4 third shift employees, maybe we wanted more employees from a certain shift to give information, or for some reason we want a particular outcome, knowing the probability can help us know how long we need to go until our chance of success is good enough. So knowing an individual probability will give us something measurable that we can use to determine how long experiments can be, or even the relevance of things that we picked out. And so counting our sample space matters. And so we need to know how many outcomes are in our event. So we're going to have 12 employees in the third shift that we're going to choose 4 from. Because it doesn't matter which order we choose from the third shift. In fact, the order doesn't matter here. And so that gives us the number of outcomes where we've picked the third shift employees we want. But for each of those third shift that we encounter, there's a chance in the other 4 of us picking from here. And let's see, there's 0, carry 1, there's 40. So that's 40. Choose 4, right? 0, carry 1, yeah, 40, choose 4. And so our fundamental counting principle says that the number of events or the number of outcomes in event E is going to be the counting how many times this can happen. And so there we have the numerator of our probability. Now we need to figure out how many outcomes are in our overall sample space. And so of these 52 people, well, we're choosing 8. And so the sample space is going to be 52, choose 8. And so the probability of getting exactly 4 people from the third shift is going to be 12 combinations 4 times 40, choose 4, divided by 52, choose 8. And so this will give us our probability of getting exactly 4 third shifters. So if I come over to the calculator here, and we'll put this together. Turn on. I'm going to put my numerator in parentheses. And so I had 12, choose 4, right, times 40, choose 4. All divided by 52, choose 4. Or choose 8. My apologies. And so we have about 6%, right? 0.06. 0.0601. 0.0601. So we'll come back over here. And we'll say the probability is 0.0601 of us drawing 4 people from the third shift from this particular grouping of shift employees. Now, some things to notice here is, notice that these two have to add up to the total, and that these two have to add up for the number of things we're picking. And so when we have this type of where order doesn't matter, permutations or combinations where we're going across our probability space, watch for these bits to add up here. All right, that's I think most of the videos I have for Chapter 3. If anyone has particular problems, send them to me, and I'll go over the problems in particular, and I'll start posting the stuff on Chapter 4.